Hello everyone. In this video, I am going to test my custom-designed 14-channel sensor array for the fastest line-following robot. I will demonstrate how to read sensor values using different microcontroller development boards such as Arduino, ESP32, and STM32. If you are new to my channel, please subscribe and turn on the notification bell so you don't miss any of my upcoming videos. For this project, I designed the PCB using EasyEDA software and generated the Gerber files. After that, I visited the JLCPCB website and uploaded the Gerber files to place an order for PCB manufacturing. After a few days, I received the PCB, and the quality was really impressive. Then, I carefully soldered all the required components onto the PCB. Once the soldering was completed, the PCB assembly was done, and now let's move on to understanding the working methodology of this sensor. The line follower sensor operates by detecting light reflection. A light transmitter emits light toward the surface, and a light receptor receives the reflected light. Black surfaces absorb light, producing a low output, while white surfaces reflect light, producing a high output. The microcontroller uses this difference to follow the line accurately. When the sensor is placed over a black surface, very little or no light is reflected toward the light receiver. As light is not available, the light receiver remains off. In this condition, current flows through the pull-up resistor to the output, which is indicated by the red dot. As a result, the output voltage becomes maximum and close to VCC, and the microcontroller reads a high analog value. When the sensor is placed over a white surface, sufficient light is reflected and falls on the light receiver. Due to this light, the light receiver turns on and provides a current path from collector to emitter. In this case, the current flows through the transistor to ground instead of the output, as indicated by the red dot. Consequently, the output voltage drops, and a lower analog value is read by the microcontroller. Now let's look at the code to read the sensor values using an Arduino Nano. Here, I am using the same code that I showed in part 2 of my line follower robot making series, and I have only changed the sensor number to 14. Since the Arduino provides a 10-bit analog resolution for analog value, the analog reading range is from 0 to 1024. On a black surface, we get values around 800 to 900, which is close to the maximum analog value because no light is reflected to the receiver. On the other hand, when the sensor is placed over a white surface, we get values around 100 to 200, which are considered the minimum analog values. Now let's see the changes required for ESP32. In this case, we only need to change the multiplexer pin numbers to make them compatible with the ESP32. Since the ESP32 provides a 12-bit analog resolution for analog value, the analog reading range is from 0 to 4096. On a black surface, we get values around 3800 to 4000, which is the maximum analog value because no light is reflected to the receiver. On the other hand, on a white surface where light is reflected to the receiver, we get values around 1500 to 2000, which are considered minimum analog values. These values can become even lower when the system is powered using a battery. Now let's see the changes for STM32. Similar to the ESP32, here we only need to change the multiplexer pin numbers to make them compatible with the STM32. The STM32 also provides a 12-bit ADC, so the analog range is again from 0 to 4096. On a black surface, we get values around 3800 to 4000, which is the maximum analog value because no light is reflected to the receiver. After that, I conducted a test run using the sensor array to verify its performance. The robot is able to run smoothly even on a very narrow 1.5 cm line, and it also follows 2 cm, 2.5 cm, and 3 cm lines without any issue. As you can see in the practical demonstration, the maximum analog value reaches the highest ADC limit of the Arduino Nano, which is 1023. The most important point here is that the sensor readings remain almost the same on all tracks, even when the line color is not perfectly black. This consistency makes the sensor exceptional compared to conventional IR-based sensors. Also note that when using an Arduino with a 5V supply, a 1 kΩ resistor is connected to ground to minimize the current. That's it for today's video. Thank you so much for watching till the end. If this video really helped you, please subscribe to my channel and give it a like to get more project tutorials like this.